Thanks, Carol. Yeah, I'm really pleased that the SANS leadership has allowed me to keep that photo up for so long. So I guess let's just cut to it. By the way, this is there are a lot of different types of webcasts, right? Like some are very managerial and some are very theoretical. This one is neither of those. This is a very technical, hands-on practitioner's webcast. So yes, this is my profile photo for SANS. Again, I'm glad they let me keep that up there. I don't know how long it'll last. Primarily, my full-time job is working for a small company called Counter Hack Challenges. And if you've ever played SANS Holiday Hack Challenge, that's us. Or Core Net Wars, that's us. We also do a lot of penetration testing and other consulting. So that's where I come from. That's my background. That's why I'm interested in things like pen testing and pivoting. I'm also a certified SANS instructor. I teach usually 560 or the GPen course. Hoping to co-teach 588, the cloud pen test this summer with Moses Frost at SANS Fire. And I'm also the backup bass player in the church band. I had somebody once come through and say, "Oh, hey, what do you do here?" And I kind of shrugged and said, "I'm the backup bass player." And he goes, "Oh, you any good?" And I said, "No, I'm the backup bass player." He didn't think that was funny, but I think I'm hilarious. Also, I have a very serious job in the Army National Guard. I'm pleased that the higher ups there as well actually have this photo up in our next unit. So anyway, also my Twitter handle if you're into the Twitter thing. So enough about me. What are we doing here today? And that's pivoting. We're pivoting. That it often is necessary in a penetration test, or honestly, even just sometimes in systems administration, to go from one system to another through a third. And that's what we're going to practice today. So we will set up a range. It's going to have IP addresses like this. It's going to be set up in this configuration, right, where we're coming from some Linux attack machine, trying to get to a target that we can't reach directly, but we can reach a Linux and a Windows machine in between. So that's how we'll do that with various techniques. And this is all based around, of course, the SANS pivot cheat sheet. There's so many different ways to do this, and the syntax is always different, and how you interact with that pivot changes based on how it is. I wanted to have a single place to have all this, to be able to reference it and do these things and look up the commands. So I created this, and I have my beautiful printed version here. It didn't print double-sided on my home printer, but I've still got it stuck up on my wall with all my other cheat sheets, and I use it all the time. And I hope it's useful to you as well. If you're a defender, I'd also like you to understand a bit more about attack paths and understand a bit about how you might see pivoting in your environment, what it might look like on the wire. So this is not just for the offensively minded. How we're going to do this today, we're going to build up some hosts, and we're going to do that in AWS. Not that we're pushing one vendor over another, but I had to pick one, so I picked AWS. We're going to do it via a product called Terraform, which is a free thing that you can install on your system, and it constructs all these things for us. It's going to spin up all the Linux machines, the virtual network. It's going to spin up security groups and make the creation of the range a lot easier. And that's kind of the side bonus to today's webcast, is not just how do we pivot, but also how do we set up ourselves a little range, a little sandbox to play in when we want to practice these things. And then we'll pivot with metasploit. We'll use some native functionality from SSH and even Windows netsh.exe, and one of my very favorite tools, Netcat. So we'll do those. In order to play along, if you want to just watch and listen and learn, you are absolutely welcome to. If you want to now or in the future play along at any point, there are a few prerequisites. I'm going to demo all this in Linux. Now, I say in Linux, I'm actually on a Windows 10 desktop, but using WSL2 to emulate Linux. So if that's where you're at, if you're in Windows, you absolutely can use WSL. That's exactly what I'm doing. I also have the AWS CLI installed, so I can issue AWS commands right from that prompt. Terraform is installed, and I also have Git installed. I'm going to go ahead and just post in the general chat here a couple of links. The first one is to the cheat sheet itself, and the second is a link to a GitHub repo I'm going to be pulling from that helps us build all these things. So, but on that, it will also list these prerequisites. You have to have these software packages installed. It has links to them, so you can go there and grab Terraform if you don't have it. You also need an IAM credential in AWS. So this is like an identity. This is, I log in as Chris Elgee into AWS with my email account and my password and my hardware token, and then I can go into the IAM menu and generate some keys so that then software acting on my behalf can act as me. It uses those keys. So so an IAM credential is also required, and that also is linked from this GitHub README. So if you want to do that, you can. Excuse me. And then, all right, so those are the big things there. I'm gonna leave the slides behind for just a second and actually black those out. And I'm gonna black them out and make them stay blacked out. Okay, so what I'm gonna do is go ahead and pull that repo down. So I have here, I just gotta get around the Zoom controls. They're right where I need it. Okay, there we go. So here I am. I've gone to that link, right? The link I put in the chat there that goes to GitHub, and it brings me to this repo by some guy named Chris Elgee, and I'm just going to copy this line here. That's going to let me clone the repo. So this code is up there. It's freely available. I'm going to copy the link to it basically, and then come here in my Linux terminal and git clone, paste, and then bam, it pulled it down to my local computer. So now I have a copy of all this code on my local computer. I can cd into it. I'll use tab to complete there. And I can ls-l to see what's here. And I've got the README. I've got different scripts and things. If you notice, there are some .tf files. Those are for Terraform. Those are scripts that are built up just to run Terraform. So, so with that, let me just go ahead and start referring back and forth to that README. You can look at it in your local code editor if you want. And I use VS Code a lot. That's a great one to use. But I'll just use it right here in the web browser here. So the first thing I need to do once I have this code down is I need to generate a pair of keys. This is something that's going to be unique just for this lab. So I don't need to reuse keys I already have or anything. So so I'm going to copy and paste this command in here, and then I'm going to do the smart thing here and change the example email address to clg@sans.org. It's so official. And what this is going to do, yes, I do want to overwrite it. I've already run this lab today. So what this is going to do is generate a key pair so that I can put one half of that key, the public half of that key, in my in my range machines, and then the other half of the key, the private half, will be on my machine, and that'll help me authenticate to those hosts as I connect in. So great. We'll get pivoting, right? We're working right now on getting all this to getting the range spun up. The next thing I'm going to do, and you can do this manually with a text editor, but here's a sed command for you if you want. You can just paste it in. And what this is saying is, hey, I'd like to replace the line in these files as ssh-rsa something, something, something. I want to replace that with the contents of my public key. And we'll trim off a new line character at the end there. So what sed here is doing is it's going to look through each of these YAML files, going to look for that string, and then it's going to replace it with my public key. So if I do this, then they should be all set. Now, if you've used sed before, you might think it's a little odd that I'm using colons for delimiters. Usually we use / just by convention, but with sed, you can actually use a lot of different characters here. I'm avoiding / because that appears in my public key. I can show you that too. This is the key that my first command generated. Just a bunch of base 64 with some slashes in it. So anyway, since there are slashes in my text there, I'm using colons to delimit my sed command. All right, so that has my scripts more or less ready to go. The next thing I want to do is just make sure my IAM credentials are all set here. So what I encourage you to do if you are on a private machine at home is just cat out your .aws credentials file. I'm going to do it a little differently because if I do this here, you'll actually see all my private keys, and I'd rather not give everyone my private keys. So I'm going to cat that file and then just grep for the header sections here. So you see, I have a few different keys on my machine here: a default, an Elgee management, which I'm going to use today, and then one for building stuff with SANS. So the next thing I'm going to do is just tell, I want to tell Linux going forward in this shell if anything is asking what my AWS profile is, I want to use Elgee management. So I've got these different identities, right? I have more than one login into AWS. Terraform. Hey, Terraform, when you are building this thing up, I want you to use the Elgee keys. I don't want you to use the SANS stuff or whatever else, whatever I have in default. So I'm exporting that variable so that now Terraform will do. All right, so hey, great, cool. We're ready now to start actually building things. So let's slide this over here so we can see both. I'm going to Terraform tab init. And this just kind of gets Terraform ready, right? Like I'm going to start building Terraform. So go ahead and get ready here in this directory. And I'm going to Terraform FMT, Terraform validate to make sure that this code I just pulled down from GitHub looks legit. And Terraform says, yep, it looks great. Awesome. The next thing I'm going to do is Terraform apply. This actually says, hey, grab like all those files, all the .t files and the scripts and all that stuff. I want you to go ahead and build things from it. It looks at them, it says, great, I'm going to build you some attack machines, pivot, target, and even like a VPC. Are you all set? Yes, I am. YES. Now, this will take about a minute or two to build up. While it's doing that, let's go ahead and look at launching a Windows instance. Now, the Windows stuff can be done from the command line, and I've got some commands down here that you can try, but it works better from the web console. And I'm sorry if you're a keyboard warrior, I am too, but this just works better from the console. So I'm going to come in here and refresh. These are my old dead ones. All right, so you can see it's already building these new targets for me. Terraform is building these new targets, but I need to build a Windows one. So I'm going to click Launch Instances. And if you haven't been in here in a while, they've actually just updated the interface here very recently. So anyway, I'm going to come in here. I'm going to name my thing Windows Pivot. You can give it other tags if you want. You know, if you want to give it a project name, like Pivot Play or something. Oops. Got my old Pivot Play. There we go. We can add different tags to it. This just helps us identify resources going forward. It can be easy in these cloud, IaaS platforms, infrastructure as a service platforms. It can be easy to lose things. It's like putting tags on things so I can find them later. All right. So anyway, I want a Windows machine. It might change some of the settings I already have. Great. And then what kind of Windows machine do I want? I haven't played a lot yet with Windows Server 2022, so I'll take that because why not? We'll scroll down through. T2 Micro is fine. All right, key pair name. Now, I'm going to go ahead and create a new key pair. You can do the same here. If you already have keys, you can use those. That's fine. But these have to be keys that were generated like with AWS. But it has to be keys that it recognizes. So I'm going to call this Pivot Play, and that'll be my key name here. All right, and my PEM file is fine. I need to save that somewhere. I'm going to save that in my WSL file system. If you don't know, from Windows, you can actually access the WSL file system with WSL $. So I'm going to do that. Come to my tools directory. It's thinking pivot play.pem. All right. So this key pair, this is going to be used specifically for the Windows instance. I've got the private key locally. It's going to put basically the public half in that Windows instance so that once it spins up, if I say, hey, I'd like the password for that machine that I just spun up that I'm invested in now, it'll say, all right, prove who you are by providing us the private key. So I've saved out that private key, and that'll help us out. Now I want to make some changes to the network settings. And by the way, these are all these things I'm doing are built into the instructions here. So, I picked T2 Micro, I made new keys, call them whatever. All these settings I'm picking in here are lined out in that README. So I'm going to pick an existing security group. This is actually a brand new one. Ooh, I think it maybe hasn't been created yet. So as Terraform is running, no, it should be good. Ends in 5482. So as Terraform is running, it's creating these things. Let me refresh it. Oh, that's interesting. Oh, you know what I haven't done? I haven't picked the right VPC. So in AWS, we have different, like basically private networks. I need to pick the one that was created for this lab. So you can see it created a VPC, ends in 6885. I'm now in the right VPC, 6885. Subnet, there's only one subnet to pick from. Great. I do want to auto assign a public IP. And the idea here is I want to be able to, from my home host computer here, connect to this Windows machine with RDP. And to do that, it kind of needs a public IP. So I'm just gonna enable that. And now I can pick the pivot security group. That's exactly what I want. And I also want to specify the IP address 2.2.2. I believe we're doing 10.1.2.2. I'm going to pick this IP address because as we'll find in these Linux machines, once they spin up, they already have an etc hosts file that knows where this Windows machine is supposed to show up. So I'm going to give it a private IP address, and then it'll give me some arbitrary public IP address. That's great. So I click launch, and off it goes. So now, all right, I have 3 running Linux instances and 1 pending Windows instance. Cool. That's enough to get us going a little further. So once Windows comes up, we'll come back and we'll connect in, and we'll set some of these options. But for right now, we can go ahead and start connecting to our machine. So I'm here in my pivot sheet lab folder, and I want to SSH into my attack box. I don't have a password for that, but I do have a key, so I can specify a key with -I. And I'm going to use the -tf-cloudernet. I'm going to use that key. This is the private key that we created at the beginning of this README, right? So that's my proof that I am me, that I spun this up, I own this, I ought to be able to connect to it. And then username attack, and then the attack IP here. So I'm actually going to grab this whole block and copy it to the clipboard and paste it in my little notes file here on the left, so I get access to these addresses. These will stay the same between mine, yours, everybody's. We'll have these same private IP addresses, but these public ones will be unique each time. So I'm going to grab that one and paste it, and then I should be good to go. It says, hey, here's a new machine I've never connected to before. Do you trust it? And I'm just playing around, right? I trust it. This is fine. I'm going to play with this for a few minutes and then turn it off. I believe that this is the one I intend to connect to, so that's great. Now, while we're here, we can look around a little bit. I'm going to come back to PowerPoint here. Oops, PowerPoint here. So we've got different hosts, right? And right now I'm on Linux attack. That's the red one on the left. I can access the 2 in the middle. I cannot access the one on the right-hand side. And let's just prove that out. So if I right now nmap Linux pivot and Linux target, I should be able to reach Linux pivot. I should not be able to reach Linux target. And that's what I find. So pivot, yep, I see it there, 10.1.2.1. I can see port SSH and port 80. Now, as per the diagram here, you can see that on the Linux pivot and the Linux target, I have HTTP servers running. I have web servers running. So as we go through, that'll be kind of our proof we've been able to reach things. So for example, I can curl Linux pivot, and it says, all right, you've reached company page on pivot. And I see you coming from 10.1.1.1. That makes perfect sense, right? I am on 10.1.1.1, and I am curling that pivot machine. If I try the same thing on the target, that's going to end up timing out. The way the security group is set up, the way the firewall rules are established, I can't go from attack directly to target. And that is, of course, by design, because we want to learn how to play with pivots today. So that's cool. Let's go now to back here. All right, so we've proven that we can connect to the pivot and we cannot connect to the target. Great. So let's go ahead and try a thing here. I'm gonna Control C to cancel that. I'm gonna exit out. And then what I want to do is copy my key up to my attack machine. We don't generally want to be throwing private keys around a whole lot, but again, this is just a lab, not a big deal here. I'm going to grab my attack machine IP. So what I'm saying here is SCP, secure copy. I want to securely copy. I'm using as an identity file. I'm using this cloud init that I used before. This proves that I have access to this machine. What do I want to copy to that box? Well, I want to copy that same key. So I want to copy that private key up to the attacker machine and drop it in the SSH folder, because that just seems like a nice place to put it. So I say, hey, go ahead and copy. It does. I'll hit up here a couple times and then connect again. So I'm back in my attack machine with one new addition. Now in the SSH folder, I have, in the .ssh folder, I have the public half of the key, which says I can connect here, and also this private key. So what this does for me, why did I do this? Well, now I can SSH into pivot, Linux pivot, with the identity file of SSH TF. So now I've got access to that middle machine. Right? This is post exploitation. I've done something already to compromise my credentials on that pivot machine. I can connect to it. Yes, I trust it. And so here I am on the pivot machine. So I've SSH'd into the attack machine and then further SSH in the pivot machine. And from here, I bet I can curl Linux target and see the final thing. And in fact, I can't. So here's my web page coming back. I can reach the target from the pivot, and it sees me coming from the pivot 10121. So cool. Now here's where the fun happens, right? When we can't just SSH forward like that, that's great. But let's say we need to do something a little different. We need to do some crazy kind of pivot. Well, here's where we can try something like a local port forward. And we're going to use this command right here, and we'll talk through it piece by piece. So this is still an SSH, meaning I'm still using that good secure tunnel to connect from attacker to pivot. I'm still using this key, this private key, to connect, because in this lab, all these machines will trust that key. And then this next chunk of options here, the big one here is the dash capital L. I want to do a local port forward. What does this mean? This means that I want to, on my local machine here, on the attack machine, I want to open up a new port. I'm already listening to 22. That's how I connected from my host, right? But I also want to listen on 1337 because it's just cool, right? That's what hackers do. When I hit that port, I want any traffic going to it to go through my SSH tunnel and come out the other side to hit port 80 on Linux target. And we'll look at this in a picture in just a second. And then I'm gonna do all this by logging in as pivot on Linux pivot. So I run that command, nothing much seems to happen, but if I netstat, I can see, in fact, I am listening on port 1337. Now let's look at our diagram here for just a second. So here we're on the Linux machine, and then with the bright yellow path there, you see I've got an SSH connection to Linux pivot. Whatever I do through that tunnel, right, through my local port 1337, whatever I send through that port is going to be encapsulated in that SSH connection to Linux pivot, and then cut the other side and hit the target. So if I want to curl things, if I want to nmap, I probably can, at least one port at a time. If I want to do whatever through that port forward, it's all going to ride securely through that SSH tunnel. So I don't have to worry about any client data leaking out here. So let's prove that out. So I should then be able to curl localhost, because that's where I'm listening, right? On port 1337, and then whatever I send through that, like the curl request, that should pass right through my SSH tunnel and hit the distant end, and then give us that end web page. And let's see what happens. Actually, when you're learning to give demos with groups like with SANS, they say, hey, don't say this is what's going to happen, because you never know, right? The live demo, you never know what's going to happen. Say watch this, and then that's so strange. You can talk it through. But here we go. It worked. So from the attack machine, via that pivot, I got to the target web page. Now, what does the target web page see? It sees me coming from the pivot IP address, right? It doesn't see me coming from 10.1.1.1. It sees what's coming out the other side of that tunnel. So that's neat. So defenders, if you're watching this, you're going to see an SSH tunnel between the attack machine and the pivot machine, and that's it. It's going to be traffic over TCP/22, and it's going to be encrypted. You're not going to be able to see what's in there. And then at the same time, or during that SSH session, there's just a web call right from the pivot to the target, and that's the only clue you really get. There's nothing else that ties that together. I'm doing some really in-depth logging on those pivot machines. All right, so that was the local port forward. We're going to do one more. This is similar, but a little more flexible. This is the dynamic port forward. By the way, these are things we do practice in 560 and other classes, 504. Right, we practice with pivots a lot because they are so handy. So again, I'm going to SSH, and I'm going to use that same key to connect. I'm still connecting to pivot because I've got these, I've got this key that lets me do that. But instead of the dash capital L, I'm using a dash capital D and picking port 9050. So hey, I'm using my SSH credentials to connect to the pivot machine. And then with that, I want to have a dynamic port forward going out the other side. So I run it. And now what we have, let's do netstat again. Now we see we're also listening on port 9050. Now, if I were running like Firefox on this machine, I could say, hey, Firefox, I'm using a SOX browser, excuse me, a SOX proxy. And that SOX proxy is right here, localhost, port 9050. And I can now browse to that page via Firefox because Firefox understands this proxy. Most tools do not. Most tools won't work that way. Curl doesn't, well, Curl actually will if you get deep enough into it, but I don't want to mess with that. I'm going to use a wrapper, proxy chains. Proxy chains understands dynamic port forwards. It assumes port 90, so I can proxy chains and then curl Linux target. Now, notice before when I did the local port forward, I curled localhost because that's how it worked. The local port forward forwards a local connection, like a local port machine through the SSH tunnel to a specific place on the far end. The dynamic port forward listens locally, but it understands different targets, right? I can pick a different target on the other end. I pick a different port. If it were listening somewhere else, I could listen on port 8080, but I don't need to specify here. So proxy chains is going to wrap curl. It's going to help curl understand this proxy thing, and then sure enough, it reaches to the intranet site on target. And again, target sees me coming from the pivot machine, right? This traffic is going to go through my other SSH tunnel to pivot and then come out the other side as a clear text web request. So those are two SSH port forwards. Now, let's back up just a little bit here because I think our Windows machine is going to be all set. Now, to do this, to get connected to this machine, let's refresh. Looks good. Sorry, the Windows machine is up and healthy. I want to connect to this now with an RDP client. Now, to get my password, I have to give it the key. Now, remember when I first set this up, I said, hey, I want to create a new key pair, and I did, called it pivot play. I'm gonna slide this off because again, this is information we don't necessarily want to share. And pivot play, there's the key. So go ahead and decrypt my password, and it does. It gives me a clear text password. I'll show you part of it. Not that I don't trust you guys. I just, I don't know who's watching. So it gives me this password down here at the bottom, right? And that is the password to connect to my Windows machine. So how do I connect to a Windows machine over RDP? Well, I use the native tool, remote desktop connection, or MSTSC. This, of course, is in the README. Talks about exactly how to get here. Save my little password in my text file. I'm going to go back to my instances, and then I need to connect to this Windows machine. So I need its public IP address, and I'm going to copy it. Thank you. I'm going to paste it here, and I want to connect as administrator with the password that I just got from AWS. So whenever you spin up a Windows machine in something like AWS, it's going to automatically generate a password for you. And you can actually get that password from the command line. I usually have better luck using the AWS PowerShell tools than the AWS CLI. I don't know if it's just me, but anyway, it creates this new password, unique password, and that's what we use to connect. And it's like 32 characters long. It's going to end up being really hard for somebody to just guess. And even if you had the hash, you would spend the rest of your life trying to crack it and probably never get there. So we use that to connect to the Windows machine, and then as we get there, we're going to run a few things just to make life a little easier. For example, I like installing Chocolatey. This is a package manager. Windows actually has its own package manager now. I think I was the last to find out about this, but sure enough, there is a Microsoft Windows package manager. I'm going to just use Chocolatey because I'm more familiar with it. Open up the PowerShell terminal there, slide it down a little bit. You notice this is running a little slowly. I did make this a T2 micro, right? So this is kind of a small, cheap thing. If you're still like in your free trial, you can probably do this whole lab and not use up much of your free credits. So if you want it to run faster, you can. You can make it more beefy. So anyway, so I'm going to just paste command blindly here into the PowerShell terminal, and this is going to install Chocolatey, a package manager. Once that's in, then I'll be able to install things like Nmap or whatever other tools I want here in the lab. While it's doing that, I want to make an edit to the hosts file. So in Windows, just like in Linux, when the system is trying to resolve a name to an IP address, one of the very first places it looks is the hosts file. In Windows, it is in Windows, System32. They make you work for it. Drivers, etc, hosts. There it is. Oops, I don't want to rename it. I want to open it. And I want to open it in Notepad. Slide it down a little bit so I can get to it easier. All right, so here in the hosts file, I can give different names and IP addresses. Let's come back here so I can just steal this from the README so I don't have to type it in or find it somewhere else. And then I'll save that. So now on this machine, when I reference Linux pivot, Linux target, Windows knows where that is, right? You can resolve that name back to the correct IP address. Oh, good. It's down there. So, so let me just go ahead and choco install nmap. And this is how it works, right? Once you have chocolatey or another package manager installed, it's almost like apt install or yum install in Linux distributions, right? We can just choco install nmap or notepad++ or whatever tools we might want. So great, that's going to run for a bit. It's going to ask me if I'm sure. By the way, I do have the question window up. If anybody has any questions about what's going on or different ways to do things, feel free to drop them in there. I will see them and answer them as we're going through. Also have some time at the end to ask anything else that maybe didn't come up. Yes, great question, Jord. The recording will be available as early as the end of the day. I don't want to push Carol, but I think usually they're up pretty quickly. So yes, the recording will be up. By the way, too, that repo, if you use that and find it useful, great. If you'd like to see any changes, by all means, please issue a request to do that. And yeah, Carol says the end of the day, the recording will be up. But yeah, I'm happy to make changes to that repo. If, for example, I'll take pull requests too. If somebody figures out an easy way to spin up this Windows instance without doing all these extra steps, I would love to see that. I've spent a lot of time trying to figure that out. I think it's possible in Azure to just, from the command line, create a machine and make changes to it and do all that, but it's not, and we're not quite there yet with most cloud providers. So anyway, we get that running. That's great. Windows is nearly where we need it to be. Let's get back to our sheet here. All right, so Windows is spinning up, is getting all caught up. We did those forwards. Oh, netcat. I love netcat. I think it's just such a wonderful, flexible tool. And maybe I'm weird, but because it's so simple, right? Like there's not much to netcat, but that's kind of part of the power of it, right? We can really make it be whatever we need it to be. So what I'm going to do here first is a little bit of tmux. If you haven't used tmux before, it's a neat way to get a little more power in your console, right? Let's you split things around, and that's exactly what I'm going to do. So right per the instructions here, I'm going to Control B and then double quote. That splits my terminal in two. I'm doing this because I need to do two different things at once, and I don't want to log in separately and be working within separate tabs here. I want to have it all on one screen. So tmux is a great way to do that. You can split things different ways and jump around. All right, so I've done that. I've got my terminal split in two, and then I'm going to go ahead and connect into the pivot machine. So the assumption here is that we've got some access to the pivot box, right? But we don't have direct access to the target. So while we're on here, I'm going to create a pipe. MK FIFO. We call it backpipe. You can call it whatever you want. That's just kind of a convention that a lot of folks use. And then with this pipe here, it's going to allow me to connect two separate sessions. So what I'm going to do here is from this pivot machine, I want to listen mostly on port. We'll use the example there, 2000. And when things come into that connection, I want to forward them on to Linux target on port 80, right? So I want to be able to connect into pivot from a hack machine. And then whatever I send there on port 2000, I want that to come out the other side and hit the target on port 80. I'm trying to curl a web page here, right? So I need to hit port 80. So that's great, but that's not totally going to work. This will pass bytes and data from my attacker to the target, but there's no path for that to come back. Any response from the target is going to end up landing here on this pivot machine. That doesn't do me any good. But if I use this backpipe thing to write all data out, then I can bring it back. So I'm saying, hey, listen here on port 2000, and then whatever you get, pass it through the pipe here to Linux target on port 80. Whatever comes out of that, I want you to write it to this backpipe thing. And I'm writing to it like it's a file, but it's not a file, right? It's a lie. Linux thinks everything is a file, and it's not. This is a FIFO. It is a first in, first out. It is a named pipe. So when things get written to that pipe, they have to go somewhere. Well, where do I want them to go? Well, I want them to come back here to my original netcat connection. So, oh, yeah, that happens sometimes. I'm not sure if this is because I'm using tmux or what here, but I'll just be specific. I'm gonna do that. Temporary, fine. Oops. Put another and here. So don't resolve names. Okay. So it's listening to 2000. The live demo. I'm going to control B and up arrow. So now I'm up here. Hello. And notice up here, I'm still sending commands to the attack machine, right? Where down here, I'm sending commands to the pivot machine. So great. While I'm down here, I can now curl the Linux pivot on what port? What port do I want to hit? I'm going to hit 2000, right? So I'm going to say 2000. And what should happen here is that I connect up to the pivot. It hits this netcat listener, right? And then whatever I send in, like this curl request, should get pushed right through to the target machine, excuse me, on port 80. And then backpipe should bring all that response back to us. So watch this. And there we go, it works. So through the magic of a simple thing that is just the netcat port relay, I hit that intranet site on the target machine. And again, once again, it sees us coming from pivot, and that's fine. That's kind of expected. Now, defenders, what do you see this time? We're not riding through some secure tunnel, right? This is just a plain netcat port forward. So you're going to see a curl request go over 2000 to the pivot machine. You're going to see an identical curl request going to the target machine there over port 80. And then you'll see the responses trickle back the same way. So a little bit different. We do have some capability here to be a little more secure. Tools like NNAT have a -SSL option. Sorry, -SSL that lets us have at least some kind of TLS connection between the two hosts. So anyway, so that is the netcat port pivot relay. I just think that one's tons of fun. What else can we do here? So we've seen some Linux things. Let's do some Windows things. The first thing I'm going to do is I'm going to create a venom payload. So part of the metasploit framework, which by the way is installed in this attack machine just by virtue of having spun it up with the terraform scripts, right? Metasploit's installed here, and it has this wonderful tool called MSF Venom, that Metasploit framework Venom, that lets us just build payloads and specify what kind of payload. Well, I want an interpreter, which we'll play with here in just a minute. I want it to be reverse TCP. So I want this thing to call back to me on my system, because I can't reach target directly, right? But target can reach me. So I want it to reach back to me. I want it to hit my ETH0 interface. I'm going to listen on port 8888. What format do I want this in? Do I want this as raw shellcode? Do I want like a PHP thing, a .war file? No, I want an exe. I want this to be something I can just run in Windows. And I want you to output it to a file called helper.exe. And sure enough, that's exactly what it does. So I created this file. I can see it's helper.exe. If I file helper.exe, I can see it is a 32-bit executable for Windows. So cool. I just created brand new malware, right? And if I Python, again, right from the README there, this is an easy way to push files around a network. Is a Python web server. So that if we're, say, on a Windows machine, if we're on a Windows machine, we can just curl and pull files down. But first, this is malware that's very easy to create. It's very easy to detect, right? Defender has gotten much better over the years, which, you know, puts us out sometimes as attackers, but that's fine. Make the world more secure. We're going to turn Defender off. We're also going to turn off the firewall, because that can get in the way sometimes. And especially in labs, we don't want those things, those pesky firewalls getting in the way. So I'm going to shut those off. And of course, those commands come right from the README. Once I've done that, I can pull down the helper file to my Windows machine. So I'm going to just curl it. I'm going to go to the attack machine from Windows Pivot. I'm going to download helper and save it to helper. And sure enough, helper, it couldn't be evil, right? It can't be malware. It's called helper.exe. It's going to help me. Now, before I run it, I need to make sure I'm ready to receive that file on the other end. So I can Control-C to end my Python web server. Thank you. You did a great job serving up one file. That's exactly what I needed. But now I need to get Metasploit ready. And this is just kind of a quick way to do it. I'm going to, you can do something like this. You can cat into a file and then type things in, and then Control-D to send an end of file, and then you get a file. I'm going to delete that file, rm file.txt. Another way to do this is you can cat and then less than EOF, and then write to, I want to make sure I match the name here, catch 8888, catch.rc. So I'm saying, hey Linux, I'm going to give you a bunch of text. When you see the string EOF, that means I'm done giving you that string of text. So, so I'm going to copy this to the clipboard, and I'm going to paste it in here. Yes, paste anyway. And now I have that file. So if I catch, and I see I've got this file. So this was just a quick way to create a file, which will let us launch Metasploit a little more quickly. So I can now MSF console, reading a resource file called catch, tab. And then, so what we've said is, hey, MSF console, Metasploit framework console. When you spin up, I want you to just go ahead and do these things. I want you to use this multi-handler module that's going to catch a shell coming back from Windows. I want to, when it connects, this is the kind of payload we're going to be sending. I want you to listen on this port, on this interface. And now, sure enough, it is listening on 10.1.1.1 on port 8888. So at this point, we've created malware, we served it up, and then downloaded it to the Windows victim, the pivot machine, right? And then now on the Linux machine, we're ready to catch that shell. So that if we come over here on the Windows side and run /helper, we don't really see anything in Windows, right? It doesn't, there's no alarm bell that goes off, nothing that flashes, mainly because we have Defender disabled, thank you. But on this side, we see we've got a new interpreter session. So I just got a shell. I got a shell on myself, but it's still fine. I still like the shells. So if I sysinfo, I see that sure enough, I am on this other machine. I can pconfig and see that I am on 10.1.2.2. Great, that is the Windows pivot machine. Wonderful. And we can do all kinds of weird things here, like hash dump to get system hashes, and great. That's that hash that I'm never going to be able to crack for that administrator account. We do other things like do keystroke logging and get screenshots and stuff like that. But today we're focusing on the pivoting. So if you look at the pivot cheat sheet, there is a interpreter port forward on the inside of that trifold. That works a lot like the netcat one. We're going to do something that's a little bit different here. So I'm going to background my interpreter session. So I still have this session, right? If I sessions-L for list, it says you currently have an administrator session on this machine. It is session ID 1. That becomes important. So once we've got that up, it's running, it's wonderful. I'm now going to use this autoroute function. So I've backgrounded my thing. I can now paste in use autoroute. What is this module? If I type info, I see, all right, this is something that's going to help us just route other things. So if I want to run more Metasploit commands through this exploited session to get somewhere else, autoroute helps us do that. So I can set subnet tab 10.1.3.0. So dear Metasploit, I want to set up a route for anything that's in 10.1.3. That's the target subnet. I want to set up a route to get there. How do I want you to get there? Well, by using session 1. That's the one I already made, right? That's the session I just created. So it's up, it's working. When I use Metasploit modules to get to anything in this subnet, I want you to do whatever I tell you to do via session 1. I can then run or exploit. If you're feeling like super lead, you can exploit. It's more or less the same thing. So there we go. That's it. That route is now set up. So now if I want to use something else just to verify this is working, like how about a port scanner? So I'm going to use a port scanner, a TCP port scanner, and say, hey, I want to scan 10131. For the sake of time, I'm going to set the ports to just port 80. Normally I couldn't do this, right? Normally I couldn't just scan that machine from the attack machine because I don't have a straight path. But since I've done this autoroute thing, it should work now. It should go through my interpreter session and then out the other end. So let's run and see. In fact, yes, TCP open. So I've got this interpreter session with my Windows machine, right? From the attack machine to the Windows pivot. This is also a fully TLS encrypted channel. So Defender, you're going to see something going on port. I picked 8888 and it's encrypted and you can't really see what's going on there. Now I issued this scan thing, and what you would see out the other end is a TCP scan, right, of a single port going from the Windows pivot to the Linux target, and then that's what we get. So that gets us to using Meterpreter. So again, the sheet has lots of different ways to pivot. We've gone through some of the most common ones. I want to do just one more because I think it's neat that some of this functionality exists natively in Windows. We think of Linux as being, the nitty gritty, super powerful command line, but Windows for a long time has had this netsh command. You saw me use it earlier to turn off the firewall. It has other nefarious purposes as well. I can also set up a port proxy. So here's a command where hey, port proxy, I want to add a new one. I want you to listen on port 4000. When something connects to this, I want you to reach out over port 80 to the Linux target. So this is a lot like that netcat port pivot relay, right? It's just a very simple way to go from A to B. So if I come back to my attack machine and I exit, I really want to exit, and now curl Windows pivot, oops, port, what did I say, 8,000, 4,000, 4,000, sure. It should hit that netsh port pivot and ride right through and get to the far end. And in fact, there we go. I got to that internet page on target. It sees me coming from the Windows pivot machine from 10.1.22. So that's cool. That's a lot of fun. Okay, I've been talking a lot. I would welcome some more questions. We're actually getting close on time here. So I'm going to go to the end of the, it's our next step here is to terraform destroy and just start tearing things down. Just so you can see, oops, that's not going to work here because I'm inside my Linux machine. All right, so I'm going to back out of that machine and then terraform destroy. It's going to say, hey, here's what am I going to destroy? It checks on all the things it's built, the VPC, the security groups. It says, hey, I'm going to nuke all this stuff. Is that okay? I'm going to type YES. Now, since we didn't create the Windows machine with Terraform, we have to destroy that one just directly. So I'm going to reach in here, instance state terminate, because I don't want to pay for this overnight. I'm not using it. Sorry, not sorry. And then all this will tear down. So, so that is the bulk of what we've got today. We've shared links to the pivot cheat sheet, shared links to this this repo that you can use to build your own little test range if you want to play with any of these things. You're also welcome to try any of these things on your home lab. If you're like me, you've got a couple Raspberry Pis lying around, and those are lots of stuff to play with these types of techniques. And we've got every keystroke we need to type here in the cheat sheet. So if there are any other questions, please go ahead and type them into the question section. Take a drink of water here. What we type. All right, well, seeing none, I know parts of this probably went by quickly. If you're newer to this, and I think we've got the sheet, we'll get that README in the repo where you can do all this at your own pace. And also, of course, the recording will be available. Oh, great, couple of questions here. One from Jason, might be a silly question, never a silly question. How many attackers out there use off the land tools like Netcat? So That's a wonderful question, actually. A lot of them, right? So some of the more advanced adversaries, the more profitable criminal groups, um, the state-sponsored APTs, any of your better pen testers, right? They're going to have a lot of their own kit, but we're also going to use all these living off the land type binaries. Absolutely, we're going to use netsh. We're going to use native PowerShell functions. We're going to do all these things. So yeah, it's cool that there are all these crazy tools, right? Like Meterpreter and whatever else. But yeah, we absolutely use these native tools. Basically, attackers building their own versions that may not be caught. Yeah, so on a pen test, we definitely do both, right? We're going to use the native things. We're going to run our own stuff. But then that gets all into antivirus evasion, which is outside the scope of this one, right? We just turned AV off. That made it a lot easier to run the demo. But yeah, that becomes an issue. Is getting around those types of things. System owners often say we don't need MFA or RDP or SSH because we have EDR or anti-malware. Yeah, and that's fine until someone gets around it, right? I feel like we're moving past the point of the perimeter is the primary defense, right? I feel like we've moved forward to where they say identity is the new perimeter, right? Like we're now to the point where your federated Microsoft identity is now the firewall. That's the edge of the network, right? Because you're not going to firewall off Outlook.com, right? Everybody has access to Outlook.com. It's can they get Chris Elgee's email account? So I've got to be using, like you said, MFA. I've got to be using different techniques, and hopefully we'll get some good, user behavioral analytics stuff going on to detect odd activities. Would some sort of Linux-based anti-malware make this pivot a lot harder or just marginally harder? So Milo, that's a good question. There is a ton of great Linux anti-malware out there, and most of what I did on the Linux side was with just things that are already there, right? Things like Netcat and SSH. These aren't malicious tools, right? Most things aren't going to pick those up as malicious actions. But maybe if you're looking for things specifically like pivoting, right? Maybe you have disabled gateway ports. You've disabled in your network and on your hosts the ability to pivot from a host via SSH. Then that may save you. And maybe when we generated that payload, maybe as we're passing that around, that might have gotten caught, but that was on our attacker machine. So I think your anti-malware is going to be living there. Yes, defense in depth, absolutely, and that's part of the benefit, I think, of demonstrating pivots on things like penetration tests is showing that, okay, maybe we only got a shell on one external system, but look where we can go from there, right? We can go from the DMZ to the developers group or to the operations, and then get into the SCADA and ICS, right? So it's important to know that that we can move around, right? Lateral movement is part of how we do attacks. We penetration testers, and of course the actual bad actors themselves too. Christopher says thank you. Just started 504 on demand. Is your first SANS course. Welcome to SANS and the fire hose. Absolutely. Yeah, I hope you find a lot of use in the lab there. Josh Wright, the author of 504, he's done some wonderful work too with that VM and with those labs. There's going to be a ton of things that you're going to be able to do right within that 504 VM that you don't even need connectivity up to AWS or anything. But yeah, it's great to have lots of tools available to us. So yeah, glad to have you, Christopher. Great first name, by the way. I think that's maybe the best first name. I'm pretty sure. Carol might disagree. That's okay. So that means any other questions before we sign off? Do you have any tools in Docker Hub? Robert, no, I don't have any tools in Docker Hub. So we could, we could build some of this stuff as Docker images, right? And then just have those saved up there for other people to pull down, like Robert's talking about. And in fact, a lot of that tooling that we talked about in the 504 VM, a lot of that's Docker based. That's a wonderful way to do those type of targets. In fact, a lot of the targets we build for Net Wars and the SANS holiday hack are absolutely Docker container, because it's just so easy to consistently and with little resources, little system resources, create these different hosts that can perform specific functions for us. So great. Hey, Ben Allen. Yeah. So Robert says he uses the metasploit Docker container to keep up to date, and that's a great way to go, right? A lot of these tools are kind of cumbersome to install, and they have lots of weird dependencies, and they conflict with each other. So when you have something like metasploit in a Docker container, then you don't have to worry about all that, right? It's just going to run in its own. It's not quite a VM. It's something a little thinner than a VM, but it's all self-contained, right? So we don't have to worry about different tools stepping on each other. If there are no other questions, take one more sip of water here. Let's go to my contact page there. And I guess I'll hand it back to you, Carol.
All right, well, thank you so much, Chris, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.